All right. So yesterday we knocked out long division. We finished it all up. Today, we're going to start off with just a really simple question. I don't know why that's not clearing. And my immediate question for you guys, and I want you to talk with your neighbors for like 20 seconds. Why do we factor? That is the whole point. Why do we factor? I'm going to give you 30 seconds. I'm going to call in a couple random people. If we want to just have a single easy phrase to say what's the point of factoring, it's to find the x-intercepts. Like, that is the shortest way to go through it. It does give us a simplified version that's nicer to work with, but specifically it's nicer to find the x-intercepts. That's what makes it nicer. So our focus in 3.5 today and tomorrow is going to be really on the zeros of polynomials. Okay. This idea is going to keep showing up over and over and over. And there's a million different contexts for which this is going to work out for us. And that's it. Now, as we go through these things, right off the bat, our first little section, we can think about algebra in a couple different ways. We can think about it graphically by drawing all the curves and those fancy things, which I know you guys love to draw your graphs every time. Like, nobody likes it, right? I don't assume anyway. Or we can do it analytically, which just means without ever graphing it, we can still answer all the same questions about the graph just by doing a little bit of algebra behind it. So as we look at this, we are going to talk first about the roots. And then in parentheses, I just want to make sure that we all have this locked in. What are some of the other words I might say? Zeros. Solutions. And just so you know, zeros can be spelled either way. It's not me misspelling it. I just switch every time I write it. Zeros, solutions. X-intercepts, somebody confidently whispered from the back. So we are looking at these roots, or zeros, solutions, x-intercepts, and graphs. Now, as we go through all of these things, there's a few different types of ways we might be able to think about these problems. And we forgot a bell ringer today, but we're just going to keep rolling. As we're looking at it, I want us to graph through factoring. And we're going to see if we can't make sense of it. Because if we don't want to have to make a table with like 50 points, maybe there's a better way. Question, issue, concern? We did do a bell ringer. Just kidding. Scratch that. Weird. All right. So right off the bat, we're going to do an example. And we're not going to see anything like brand new other than we're going to start applying all the stuff that we've been talking about. So we're going to use factors to help graph. And I'm going to say use factors to sketch f of x. And we'll define f of x specifically here in just a moment, but we're going to factor it to sketch it. So as we're looking at these, what I want to do is I'm going to switch colors several times here, but we're going to really, really annotate the steps that we do in a more general process while we're doing this example simultaneously. Okay, so here we go. On example A, I want us to use the factors to sketch, and we're going to sketch the graph of, let's say it's f of x equals 4x cubed plus 4x squared minus 24x. Okay, we are using the factors, and we inevitably will run back into our division stuff as we're going. RJ, I was coming over to wake you up, but you're not sleeping, so you got me good. Okay, as we're going through this, we will see division show back up, but we're just going to jump in here. We have a cubic thing up on the board, and all that means is the degree is 3. Quick check with your hands on the count of 3 for this function f. I want you to show me the end behavior. Don't do it yet. Don't say it. Just on the count of 3, you're going to give me one of the 4 sweet moves from the math dance. Okay, 1, 2, 3, go. All right, so I saw some changes at the end. Real quickly, there's still some debate. I see up, up, or down to the left, up to the right. Okay, what's the degree of this function? It's 3, which is an odd number. What's the leading coefficient? Y equals positive x is also positive and odd. It looks like this from your perspective. This is what your hand should be doing right now. Down to the left, up to the right. That's this move. Okay, now with that in mind, we need to factor this. So we're going to go through, and I'm going to be switching colors as we need. But step one, and we're just going to work this out, and sometimes it'll be given, sometimes it won't. Steps. And let's see, I'm going to do this one in purple, or pink, whatever color this is. And I know that's usually just a thinking color, but I want to switch for each step. Step one, we're going to factor. That's it. Okay, so on our example, we need to factor this thing. And let's just see if we can. What's always the first step, or stop, rather, along factoring? GCF. Is there a greatest common factor between these three terms? A 4 goes into all of them for sure, and an x goes into all three of them. There's a 4x that comes out, or divides out, factors out, whatever language you want to use. If I took a 4x from this, what do I need inside still? X squared plus x minus 6. Okay, this one, right now we have two factors on the board. Can you guys see this color? Okay, it's kind of dark when I'm looking there, but if everybody can see it, I'm okay with it. Are we done factoring? No. Does this one factor any further? No. So we'll just leave it, and I'm going to leave a little bit of space. Is there anything nice about this trinomial, my other factor that's here? Ooh, the leading coefficient is 1. Liam, I like your thought, but I'm going to break it real quick. What's the square root of negative 6? Okay, but I like the idea. Like, good looking out. Okay, it's a 1. Can you guys tell me any factors that multiply to be negative 6 but add up to a positive 1? So those add up to the wrong thing. They have to add up to a positive 1. Negative 3 and negative 2 makes positive 6. Adds up to negative 1. Hey, I think a negative 2 and a positive 3 will work. Like, and I'm not listing them all out. You guys gave me a bunch of numbers that are like certainly valid and possible, and it's reasonable that you would give me those. But remember, we need multiply to this and add up to the middle term. So negative 2 and 3 will do it. Those add up to 1. Okay, why do I care it's a leading coefficient of 1? How do I do the shortcut? Minus 2 and an x, and here's my other one, plus 3. This works if and only if the leading coefficient is 1, right? Okay, has to be 1. So here we have it. We have factored. Now, I'm going to put this as its second step, but it could be counted here. From this, now that we have the factors, a few minutes ago we discussed like the importance of factoring. What are the factors really for? To find the zeros. So let's use that. We're going to find roots or zeros, however, intercepts, whatever you want to call them. I'm going to call them zeros because it makes sense in my head. Use, and you can just say find zeros. I'm fine with that. I'm going to be specific, though. We're going to use ZPP, which, what is ZPP again? The zero product property to find roots. Okay, so this is step 2, and it's all in green now. So if I set this equal to 0, and this line, whether or not you write this line out as its own is entirely up to you, but you guys are going to help me real quick. How many factors have we written here? I see at least one person showing it. 3 of them. Okay, here's one, and then here's one that's a different, slightly different looking. What value of x makes this first factor 0? And that's always a weird one, but it's 0, right? When x is 0, 4x is 0. It's an odd statement. What value of x makes this factor equal to 0? Positive 2 and negative 3. Now, just in case, if you're looking at this going, how on earth did they get those numbers? Because these are nice and simple equations, if you set just x minus 2 equal to 0 and solved it for x, you would get a positive 2. If you did x plus 3, you're going to get a negative 3. And we're just solving that equation, but they're one-step equations, so we're just doing it without any work. Sonny, did I lose you? Are you sure? Okay, so we have found the zeros. Everybody cool with that? Okay, from here, we'll switch to step 3. And this one, your book does it a little bit differently. Just so you know, your book uses a table. They use it like they make a big table. I don't use a table. I do it slightly different because it's going to apply again and again and again. And we won't use tables in the future, so we won't even do it now. We're going to put these roots on a number line. Now, we have done something like this before when we did our radical or quadratic inequalities, but I'm going to put these 3 roots on a number line. And again, we're just sketching, right? We're not making a big table. We're just going to have a rough picture of this graph, but it's going to be pretty good. So as I look at this, I'm going to put all of these on a number line. And I'm going to be very, very clear because we have this function that has a name. It's f is what it is. I'm going to make sure it's very clear that we're talking about f of x here. Okay, which of these numbers is the furthest left on my number line? All right, so notice I'm going to pay 0 thought to my scale. -3. What's the next number? 0. And the next? 2. Now, because we're just sketching and I don't need specific values of stuff, I'm going to be able to use this to make sense, and we're going to, we'll see that it's super nice the way that this works. We'll even check with Desmos to see how close we are. Our graph will not be perfect. That's okay. If all we're doing is sketching, we just want the general characteristics, this will be enough. It will suffice. So, first question. When I put those 3 numbers on that number line, I have split that entire number line into some number of sections or intervals. How many different intervals do we have here? Just 3? Talk with your neighbors. I don't think it's 3. Why not? I heard Naomi say it. Don't shout it out super loud, Naomi. Why is it not 3 is the question at hand. Give you like 30 seconds. As we check this, I think there are 4 regions. Now, don't shade yours. I just want to highlight them, and I'm just going to do it all in the same color. Everything left of -3 is its own region. There's 1. Everything between these is 2. Everything between these would be 3. And everything from 2 to infinity would be the 4th region. There are 4 different parts of my number line. Okay, as we look at these, I'm going to make this in the same step. We're going to put the roots on a number line, and then I lied. I'm going to switch colors for one more step. Step 4, and it's going to still use this picture, but I'm aligning by color. You guys probably aren't. If you ever want to, just so you know, I have like hundreds of pens and colored pencils and stuff. It's always available to you guys. Okay, we're going to check a point, and really, we only care about checking the sign of the function. At a point, and I'm going to put in parentheses that's specifically the x value, in each, and I'm going to say in, and I'm going to underline that because that's super important, each interval. Now, whether we call them intervals or regions, they're interchangeable. There were 4 regions on this number line. There are 4 distinct intervals that we're checking. Now, we will get some shortcuts out of this eventually, but I'm going to wait until we see them because it's pretty obvious once we see it, but I don't just want to give it for free. 4 regions. I don't care where we start. I'm going to check the sign of my function in each of those. Okay, first region here. Joselina, can you pick any number between -infinity and -3? Any number in between them. Pick any number between -infinity and -3. -2, wrong region, but I like it. Something a little bit more negative than 3. So what if we're left of -3, more negative? There we go. Okay, now -5, -6, anything would have worked as long as it's between -infinity and -3. Okay, this next part. If you're zoning out right now, I'm going to really draw your attention and say stop for a moment. I know that that can be hard. If you notice anybody next to you zoning out, give them a tap on the shoulder or something real quick. Most of you guys are making eye contact with me, so that's okay. All right, this next part, we're going to show varying amounts of work. Step 4 says check the sign of the function at a point or x value in each interval. This first interval, I've chosen -4. Does everybody agree that that works? Okay, we need to check my function. And here is, I don't have a nice way to write this, but I need ears open, and I'll repeat this over and over. Is this my function? Is this f of x? That's it, right? Is this still f of x? Is this still f of x? Is this still f of x? So any one of these is okay. If I have to plug into them, it doesn't matter which one I pick. They're all different forms of it. If I needed to plug in -4 and I don't care about the number and I only care about the sign, should I plug into the original or the factored, do you think? So either one would work, but Sonny, I'm going to ask you a question real quick. What's 4 times -4 cubed? And that's a hard question, right? Now, here's the weird part about it. Do we care about the number based on that statement at step 4? Do I care about the number, or what am I checking, the what of the function? The sign. I only care whether it's positive or negative. That's all I care about. Don't care about the number. I will typically plug into the factored form because it's easier, and we'll see why it's easier. I'm going to make a note here, entirely up to you guys. I'm going to use in this one at least, the factored form that we have above. I'm just going to say using factored. Okay, so check it out. If this is my factored form of f of x, this right here, and I plug in a -4, here's all that I really think about. If I plug it in to this, do we all agree it's going to be 4 times -4? Okay, now this is the weirdest thing because we don't care about the number, I just care about the sign. If I do 4 times -4, is it a positive or a negative sign? Do we all agree it's negative? Now I know it's -16, but notice I don't care that it's -16, I just care that it's negative. What if we plug in a -4 into this piece? Negative or positive? -4 minus 2. So -6, but again, I don't really care about the 6 part, I just care about the negative. What if I plug a -4 into this part? -1, but again, don't care. Do we all agree that it's going to be a negative number times a negative times a negative? And it's odd, and I get that. What's negative times negative? Times negative. Do we all agree that my function is negative here? And what does it mean for a function to be negative? This is below the x-axis. That's all this means. Below x-axis. Which when you guys gave me the end behavior at the beginning, you said it went down to the left. Does this agree? Really far to the left, is it going downward to negative infinity forever? If I do this with my hands, as I go really far left, do I keep going really far downward? And would it make sense if I go down forever that I'm at a negative number? These agree. Okay, pick a number in this interval. And I'm going to draw to each interval. Notice I'm never going to put another mark on my number line. Never going to put anything other than my roots. What's the number in this interval that we could check? -1, -2, -2.7. I'm probably just going to choose -1. I want you guys to do the same thing here. Negative or positive if I plug in a -1? The first thing would be 4 times -1 is a negative, right? What about the second one? If we do a -1, -1 minus 2. Negative? What about the third one? -1 plus 3. Positive. What's a negative times a negative? Times a positive. Positive, right? What does this mean with my graph? Not goes up. At this interval from -3 to 0, it's above the x-axis. I want you guys to do me a favor. You're going to, or finish this problem, at least this part, you're going to help me pick these values and you're going to tell me the sign. Give me something between 0 and 2, Fred. 1 is a good choice. And Chetty, something between 2 and infinity. 3 is a good choice. I want you guys to tell me the sign of the function at 1 and at 3. I'm going to pause it, give you a moment, and then we'll check it. And we are going to get to the culminating point of this right now. Tomorrow, I guarantee we start in with a problem much like this. Do you feel like we've really done enough to graph this function? Maybe. Like maybe. Here's what I'm going to do. Last thing we're going to do, step 5, we're just going to sketch it. Now, the number line that we just did will give us everything that we need. So here we go. Checking this out, we have a ton of information, whether you're aware of it or not. What were these 3 numbers? -3, 0, and 2. So those were the points. Be more specific. The intercepts. So can I go ahead and I'm just going to plot them, right? So at -3, -1, 2, 3, here's a root. At 0, there was a root or an x-intercept, and at 2, there was an x-intercept. Those came from our factors. Okay, we already know the end behavior goes down forever and up forever. Do we all agree with that? Only other thing I have to do, and we have 15 seconds to finish, we will. Between -3 and 0, this little region, it was positive, right? And that just means above the axis. So check it out. I should probably just go through here and then above the axis. From 1 to 2, it was below the axis. So we'll just dip below the axis. We will check out the graph of this tomorrow. You cool cats have a wonderful evening and day. No homework tonight. Sorry to break your hearts.